Hey guys, these are our notes about solving rational equations. So these are our first notes where we're going to have equal signs. Okay, here's your table of contents. If you want to fill it in, slide 14 and 15 is solve rational equations. You want to go ahead and start by putting a title on your paper. You don't have to write down the essential question, but we want to know, how do you solve rational equations? So since we have an equation, means we have an equal sign, which means our goal is going to be to find what x is equal to. So what that means is that for your problems, okay, you're going to have an answer of something like x equals 5 or x equals 2. You're trying to find an answer. Okay, this is our first set of notes where we're actually trying to find an answer to something. We're going to talk about the first problems, which are just proportion problems. You only have one example of this, and then I don't think any homework problems are, maybe one. That the way that proportions work is when you have a fraction equal to a fraction. So something like a over b equals c over d. So if you guys remember, the way that you do proportion problems is you cross multiply. So you multiply a times c, or a times d, and b times c. So you cross multiply. You have AD equals CB or BC. I guess it doesn't really matter. I should go alphabetical. BC. And then you just go ahead and solve for x. Let's just go do the equation or the problem that's like this in your guys' little notebook, your workbook that you guys have. This is on page 49. It's the only proportion problem. We're not going to follow their little steps that they have. We're going to go ahead and do our own steps. So it says solve the proportion x over 4 equals 6 over 8. So we're going to go ahead and do that by cross multiplying. So x times 8 is 8x. 4 times 6 is 24. And you set those two things equal to each other. That should be pretty easy to solve, right? You just divide both sides by 8 and you get x equals 3. You should double check your answer. Just make sure, like, is 3/4 equal to 6/8? Well, 3 times 2 is 6, 4 times 2 is 8. So it does work. Okay, so that's the only one. They have you verify the solution just to make sure that it works at the end. Okay, let's talk about rational equations. Okay, so that one's pretty easy. Proportions is something you guys have done before. But now we're going to talk about rational equations. So these are ones that are going to be in the form of, if you see a over b plus c over d equals e over f. So the variables just represent, there's going to be numbers there. Okay, here's how you're going to do these problems. You're going to multiply each numerator by all denominators to cancel. So here's how I do that. I make nice long division bars. A over b plus c over d equals e over f. So nice big long division bars. You're going to go through and multiply by each denominator. So my first denominator is b. So I'm going to multiply all of my numerators by b. If you multiply one side, you have to multiply the other. You have to multiply all of them by it to keep your equation balanced. Well, what happens is you actually cancel out the b. Then you have d is your second denominator, so you go through and multiply all of your numerators times d. It cancels out in the middle fraction. And then you multiply the third denominator's f, so you multiply all of your pieces by f in the numerator. And it cancels on the third one. So now you don't have any denominators at all. They all canceled. On top of the first fraction, you just have a times d times f. These will be numbers and variables and things. Plus c times b times f equals e times b times d. I didn't alphabetize any of them. And then you're just going to go ahead and solve. Okay, so you multiply each numerator by all denominators to cancel. All the denominators are going to cancel, and each numerator gets multiplied by all denominators. Okay. Here's some stuff we have to talk about solving. You're going to take one picture of this. Some of you might put it on the same picture. It's okay, but we need to talk about solving. When you get to the solving step, if you have no exponents, it's supposed to be a highlighter. If you have no exponents, you just have to solve for the variable by isolating it to one side. If you have an exponent, if you see an x squared or x cubed or any sort of exponents, you're going to have to get one side equal to 0 and factor it. You might start with a GCF, then you might be able to do a snowflake, difference of two squares, whatever it might be. Then you just set each factor equal to 0 and solve. The last thing you have to do is that you have to check for those invalid values, those extraneous restricted solutions. Remember, we call them all of those things. Check for invalid / restricted / excluded, extraneous solutions where the original denominators would equal 0. So that's going to be the second picture for our notes. We'll be talking about solving. So once you get to the solving step, if you have no exponents, really easy, just isolate x. If you see exponents, you have to factor, set each factor equal to 0, and then solve each of those. You do have to double check your answers, make sure they are not extraneous and that they work. Okay, I think we have 3 more examples to do. Example 2, 3, and 4. So this is on page 50 of your workbook. So the way that I go about it is I write my division bars like nice and long. So I have 5 over t. I'm going to take my negative and distribute it to the top. So it'd be negative 3 over 12 equals 9 over 3t. Okay, so I made my division bars nice and long. Okay, so here's what we're going to do. We're going to start with the first denominator, it's t, and I'm going to multiply all of my numerators times t. It cancels out in the first one, and it actually cancels out in the last one as well because the 3 and the t aren't holding hands down there. Then I'm going to go to my second denominator, it's 12, and I'm going to multiply all of my numerators times 12. It cancels in the middle one, and it actually is going to simplify in the last one though. So hypothetically speaking, you didn't do this step, it'd be okay. You would just have like larger numbers, or you might have to do factoring, so you might have exponents. But 3 goes into 12 4 times, and now all of our denominators are gone. So I simplified the fraction. I technically could have simplified the 9 and the 3 at the very beginning. Okay, so now there's no denominators left. On top, we have 5 times 12, that's 60. Negative 3 times t is negative 3t, or minus 3t, equals 9 times 4, which is 36. Now I'm just going to go ahead and solve this. Or I look at it and there's no exponent, so I can just solve it like normal. I'm going to subtract 60 on both sides. I get negative 3t equals, what, 24, I believe? Negative 24, I'm sorry, because negative 60 plus 36. And then I just divide both sides by negative 3. And I get t equals negative 24 divided by negative 3 is 8. I do want to check to make sure that my value isn't extraneous, that if I plugged it into the denominators, I wouldn't get 0. If I plugged in 8 here, it wouldn't be 0. There is no number to plug in here. And so if I plugged in here, it'd just be 8. There's nowhere to plug it in here. 3 times 8 is 24, so none of them equal 0, so that answer is just fine. All right, let's go to example number 3. So I'm going to rewrite my little fractions. I have 2 over y, make my bar nice and large. I'm going to change it to a plus sign, distribute my negative to the top, y plus 2. I'm going to put parentheses around that to remind myself that they go together, equals 1 over 3. Okay, so you take each of your denominators and you're going to multiply your numerators. Okay, so the first one is y, so I'm going to multiply all of my numerators times y. Cancels. My next one is is y plus 2, so I'm going to multiply all of them by y plus 2. It cancels out in the middle only. And then my last one is 3, so I'm going to multiply all of them times 3. And it cancels out right here on the last one. Okay, so now I'm going to multiply. I have 2 times 3 times y plus 2. So first you multiply the 2 and the 3, get 6. And then you distribute it onto those two pieces. So you get 6y plus 12. Negative 1 times y times 3. Well, negative 1 times 3 is negative 3. And times y is just negative 3y. Then we have our equal sign right here. And then we have, let's see, 1 times y is y. And then if I distribute that onto the parentheses, I get y squared plus 2y. Okay, so now here's where I look and I see, do I have parentheses, or I'm sorry, do I have exponents or no exponents? And I do see an exponent. Right here I see a power of 2. That means I have to get one side equal to 0 and then factor and solve. So I'm going to go ahead and subtract my 6y. Since the y square is positive, I'm going to keep it on that side. I'm going to subtract 12 and I'm going to add 3y. Kind of ran out of a little bit, I wrote too big. Okay, so from here, I'm going to go ahead and see what I get. Okay, I get 0 equals y squared. I add up all my y's. I have 2y, negative 6y, and 3y gives me negative y minus 12. I'm going to try to factor that. It's a trinomial. So I have two numbers that multiply to negative 12 and add to negative 1, and that's just y on my little factors. So what multiplies to negative 12 and adds to negative 1 would be negative 4 times 3 is negative 12, but negative 4 plus 3 is 1. So we get 0 equals y minus 4 times y plus 3. And then it should be pretty easy to decide on your answers if you just plug, figure out what would make 0 in the parentheses, right? You said each equal to 0. That's a 4. You get positive 4 and negative 3. I should have checked before I put boxes around them, but if you check in your denominators, if this denominator, the invalid value would be 0, here it would be negative 2, and then this one wouldn't have any at all. So both of those answers work, so they are both fine. All right, last example. I have to try to write smaller. So for our last example, I'm going to try to factor my denominators. You guys will kind of see why. The first denominator is p minus 4. There's nothing I can do there, so I'm going to go ahead and put parentheses around it. Plus p over p plus 2. I'm going to put parentheses around that because it can't be factored. Equals 6 over, I can factor this one right here. I'm going to do a little snowflake. What multiplies to negative 8 but adds to negative 2? That's a times c and b. And then p right here on my little fractions. So multiplies to negative 8 but adds to negative 2 would be negative 4 and 2. So here I have p minus 4 and here I have p plus 2. So the reason why you would want to factor your denominators is because now if you look at them, they have something in common. So we're not trying to create common denominators, we're trying to cancel the denominators, but if they have something in common, it'll be easier to cancel. So I'm going to multiply everything on the top by p minus 4. It cancels in the first fraction and the last fraction. Then I'm going to multiply everything by the second denominator, which is p plus 2. And when I do that, it cancels in the middle and in the last fraction. So now I don't even have to multiply anything for the last fraction. That's a good thing, because had I had to multiply by something, it would have just made my exponents larger. So we tried to cancel it early on, so we factored that denominator. Okay, on the top of the first fraction is 1 times p plus 2. That's just p plus 2. P times P minus 4 is P squared minus 4P equals, and then this one's just 6. All right, do we see exponents? Yes, that means that we have to get one side equal to 0. So I'm going to subtract 6 on both sides. Cancels, so I'm going to make this side equal to 0. P squared goes first. P minus 4P is negative 3P, and 2 minus 6 would be negative 4. So when I try to do a snowflake for this guy, I have A times C is negative 4, B is negative 3, and then I put my P's on my little fraction part. So I need two numbers that multiply to negative 4 but add to negative 3. Well, my options are 1 and 4 or 2 and 2. So negative 4 times 1 would give me negative 4, but negative 4 plus 1 would give me negative 3. So I get P minus 4 times P plus 1 equals 0. If you set both of those equal to 0, remember, that's how you get your answer. So this first one gives me P equals 4. This one gives me P equals negative 1. Before I put my box around my answer, I should double check, though, to make sure that they're not extraneous. So if I look at this first denominator, it said P minus 4. Well, the invalid value for that then would be positive 4. And we got that as one of our answers. So this one doesn't work. It's extraneous, invalid, restricted value. Over here, then the other invalid value would be negative 2. But the P minus 1 is good. That one is not equal to 2, so that one works. This one right here would have the same invalid values, the 4 and the negative 2, so that one is good as well. Or the negative 1 is good in the last one as well. Okay, so the key thing is to make your division bars nice and long, multiply by all of the denominators in each numerator, cancel all of the denominators. Once you multiply everything out and see what you have, you go ahead and look, do you have any exponents? If you do, you got to set it equal to 0 and then factor. If there's no exponents, then you can just solve it straight away. The notes part, I broke it up into 2 pages or 2 pictures. So the notes, those 2 pictures go on slide 14, and then page 49 and 50 goes on slide 15. And then you can go work on your homework problems. Okay, thanks.